Hi everyone. Today we are going to discuss on electricity. So to understand electricity, we need to know about the charge. So today we will focus only on charge. Let's see what is charge. So charge is the intrinsic property of a particle which determines the force of attraction or repulsion when it is placed in an external electric field. Now, a particle A, is it charged particle? How to understand? So the basic way to understand that whether the A particle is charged or not, we have to bring another charge. So if we bring B charge and if we bring A charge to B, and if A is attracted by B or repelled by B, then we can understand that A is a charged particle. So when A is placed in the electric field of B, then we can understand that A is charged or not. Now let's discuss the properties of charges. So the properties of the charges, there are few properties. So first of all, we'll discuss the attraction or repulsion property, that is like or same charges repel each other and unlike or opposite charges attract each other. Now the second property of the charge is additivity. So what is additivity? The total charge is always the algebraic sum of the individual charges. So if we have Q1, Q2, Q3 and up to Qn, the individual charges, then the total charge Q equals to the addition of these individual charges, that is Q1 plus Q2 plus Q3 up to Qn. So capital Q is the summation of I equals to 1 to n Qi. Now let's discuss the another properties, that is quantization. So what is quantization? So total charge of any particle is the integral multiple of some basic charge, and that is the charge of an electron. So Q equals to n into E, small e, where n equals to the integral number, that is in integer, plus minus 1, plus minus 2, plus minus 3, etc. And small e is the charge of an electron, that is 1.6 into 10 to the power minus 19 coulomb. So for electron, it is the negative sense. For proton, it is the positive sense. Now, let's discuss the conservation of charge. So what is conservation? There are two types of conservation. One is local law of conservation of charge. What is it? The total charge of an isolated system is conserved. That means if you have NaCl, so one electron is leaving the Na, that is becoming Na plus, and it is going to Cl and becoming Cl minus. So one charge is going from sodium to chlorine, but the total charge of that system is conserved. Now there is another law of conservation of charge, that is global law of conservation charge. So what is global law? That total charge in the universe is conserved. It can neither be created nor be destroyed. It can be transferred from one body to another body. Now let's quick review of the charge. Let's see. It is an intrinsic property of a particle which determines the force of attraction or repulsion when it is placed in an external electric field. Now, like or same charges repel each other and unlike or opposite charges attract each other. Now, total charge is always the algebraic sum of the individual charges, and total charge of any particle is the integral multiple of some basic charges, that is the charge of an electron. Now, total charge of an isolated system is conserved, and total charge in the universe is conserved, it can neither be created nor be destroyed. It can be transferred from one body to another body. And the formula we get that Q equals to Q1 plus Q2 plus Q3 up to Qn. And the second formula what we get, Q equals to N into E. So thanks everybody. Next day we will meet with another video. Then bye bye.